Hello and welcome to our 10th video on angles. I'm Mr. Chowdhury and today we're going to be looking at tessellation. So before we start this, I suggest that if you haven't already, you go and watch our angle rules lessons, especially our lesson on interior angles of polygons, and then come back and watch this one. So your first task is, using these shapes, you are going to try and fill a 9x9 grid. Using these shapes alone, you're going to try and fill the 9x9 groups. The only issue is you cannot overlap the shapes, so the shapes cannot overlap, and you are not allowed to use just the blue and the yellow one. You have to use all of them at least once, or try to use all of them at least once. You're not allowed to just use two of the shapes. So pause the video, have a go at that, and tell me what you notice. Okay, so now that you've had a go at this, let's have a look at what happened. So if you've had more than one try, you would have noticed this, and you probably would have got frustrated by doing it. But every time you try to do this, you will always leave one square spare. It's impossible to fit these shapes together on a 9x9 grid without leaving any gaps. Now if you were to do an 8x10 grid, you could fit it perfectly fine, but a 9x9 grid, it is impossible to fit them all together. You can try as much as you want, it is impossible. You could move this square to the center of the 9x9 grid and then fit all the shapes around it. That would look pretty nice, but this ties in directly to our lesson today, which is tessellation. Now before we do anything, we need to understand what tessellation is. So tessellation is a pattern made of identical shapes or an identical shape. So for example, you could take a square and fill an area with it, and it would just be the identical square would fill the area. You could take triangles and fill an area. Like we did before, we took a bunch of different shapes, but we used the same types of shapes. We had a set of shapes and we just used those to try and fill an area. That's what tessellation is. And the shapes must fit together without leaving any gaps. So similar to our example, there weren't any gaps. And the shapes should not overlap. So there shouldn't be any gaps between the shapes, and the shapes should not overlap at all. Here are some tessellations in nature. So sunflowers tessellate, honeycomb tessellates, the scales on a snake, they will tessellate. Almost be exactly identical, although snake scales do overlap a little bit, but the idea is the same. That if you look, the shapes will tessellate. The shell of a turtle, the shapes tessellate. Another one, maybe not in nature, but something that's man-made, a football, the pattern on a football tessellates. These are all things that tessellate. So what we would like you to do, and you can spend about 5 or 10 minutes doing this, is using these shapes. So using a regular triangle, a regular pentagon, a regular hexagon, a regular heptagon, and a regular octagon, try and see which one of these shapes tessellate and why. Which one of these shapes tessellate and why. And if you've done that, maybe try it with some irregular shapes. So pick one irregular shape and try and see if you can tessellate it. So this one, you're going to pick a triangle and try and see if you can make a triangle tessellate. So use an equilateral triangle, see if you can tessellate an equilateral triangle. Use a pentagon, see if you can tessellate a pentagon. Hexagon, see if you can tessellate a hexagon. So don't mix the two shapes, just use one shape on its own. And if you've done that and you're happy, maybe try and see if there's an irregular shape that will tessellate on its own. And if you've done that and you want a bit more of a challenge, maybe if you see if you can find two shapes that tessellate together. So for example, on a football, you have a pentagon and a hexagon that work together to try and tessellate. So off you go, have a go, pause the video, have a go at that. Okay, hopefully you've had a chance at doing that and filling in this table. So now let's look at the shapes that do tessellate. So the first shape we're going to look at is an equilateral triangle. And if you look at an equilateral triangle, it tessellates. And we'll look at the angles in the equilateral triangle, because that's going to help us with understanding why an equilateral triangle tessellates. So the angles around that point there in the center that I've tried to tessellate the shape are all 60 degrees, because the interior angles of an equilateral triangle are 60 degrees. Now if I add all 6 of these 60 degrees up, I get 360 degrees. Because of course, the angles around the point are 360 degrees. Now let's look at the other shape that tessellates from the shapes that we had, which is a hexagon. So I've got 3 hexagons here, and they tessellate. As you can see, I can just continue it like a honeycomb shape. I'll just continue it forever and it will always tessellate. Similar thing with the triangle, I'll continue it forever and it will always tessellate. Funny enough, with the triangle, I've created a hexagon with these equilateral triangles. So that's why the hexagon also tessellates. So the angles around that point in the middle where they are joining, where the hexagons are joining, are 120. And there's 3 of them, so 3 times 120, or 120 add 120 add 120 is 360. Which is very interesting, because that's going to help us understand why these shapes tessellate and the others don't. Okay, so now let's have a look at one of the shapes that does not tessellate. So here I've got a pentagon, and pentagons do not tessellate. So I've got 3 pentagons that I've got around this center point where they're all joined up, and I've also got a gap. Now, I can't fit another pentagon in this gap. What I can fit in this pentagon would probably be a triangle, but I can't fit another pentagon in that gap. So what happens? Well, let's have a look at why I can't fit another pentagon in that gap. So I've got these angles around that point, and I know that the interior angles of a pentagon from the last video was 108 degrees. I worked that in the last video. So if I add up the interior angles, 108, 108, 108, I need a 36, so my gap will be 36 degrees to get it to 360, because angles around a point sum to 360. So what have we noticed between this pentagon that does not work and the triangle, and the equilateral triangle, sorry, and the hexagon that does work? Well, the key thing to realize is that shapes will tessellate if the angles around a point that they join sum to 360. So if the interior angles will sum to 360, so if there are a factor of 360, that shape will tessellate. So I could, with my triangle, I could put them all around, and it will, whatever point I'm looking at where they all connect, will sum to 360. Similarly, that will work for my hexagon. However, it will not work for my pentagon, it will not work for my heptagon, and it will not work for my octagon. Now, if you understand this fact, we can look at some questions and see how we can apply it. So here's an irregular shape. So this is an irregular quadrilateral. And we want to check if this irregular quadrilateral tessellates or not. And if it does, how? So you can pause the video, have a think. Do you think this will tessellate or not? And then I'll show you why it does or it doesn't. Okay, so let's have a look at if this shape tessellates or not. So I've put this shape together, and from the looks of it, it does tessellate. But let's have a think about why. So the first thing you want to do is label all the angles A. So wherever angle A is, put in angle A. Just write A there. And wherever B is, and wherever C is, and wherever D is. So I'm not going to do that for every single angle A. I'm only going to be looking at this point here. That's the point I'm going to be looking at to see what the angles are around that point. So if I label them, so I've got A, B, C, and D, just like my diagram. This point here would be A. This point here would be B from my shape. This point is D from my shape, and this point is C from my shape. And I can see that A, B, C, and D there around that point sum to 360. Well, I already know that because it's a quadrilateral, and A, B, C, and D will sum to 360. And because I can fit them around this center point and they sum to 360, I know that this shape does tessellate because A, B, C, and D sum to 360. Now that is in essence how tessellation works. So you know the key thing to take away from this is shapes will tessellate if the interior angles around a point sum to 360. If they don't sum to 360, they will not tessellate. Now you can go off and use that information how you like. You can go and watch Mr. Ameson's videos and practice through there. If you're feeling super confident, you can go on Dr. Frost and Corbett Maths. Whatever you decide to do, just go off, be productive, and I'll see you in the next video.